Here we have AP calculus AB problem. Okay, let's go to the information. Find the x values for all critical points on f of x equals to 9 negative x square whole to the power of 3/5. Okay, so to get x values for all critical points, first I have to find domain for this function. So to get domain for this function, I'm going to do some work on this expression. So that is 9 negative x square whole to the power of, the exponent over here is 3/5. It's a fraction. This fraction 3/5 can be written as 3 times 1 over 5. Okay, so whenever two values are multiplied by the exponent, what we can do is we can take one value as the first exponent and the second value as the exponent for the whole stuff. That is 9 negative x square whole to the power of 3 whole to the power of this value. That is whole to the power of 1/5. Okay, now since the exponent is 1/5, this can be written as a radical with the index of 5 that we have in denominator. So that is fifth root of 9 negative x square whole to the power of 3. Here we have radical for this expression 9 negative x square whole cube with the index 5, which is an odd number. Since the index of this radical is an odd number, that is 5, so we can have both negative value and positive value and also 0 inside the radical. In case if you have radical with even index, so what will happen is we can take either a positive value or 0 inside the radical. So but here we don't have even value, we have even index, we have odd index. So we don't have any restriction for the value what we have inside the radical. So we can take positive value, negative value, 0, everything. So clearly the domain is all real values. Let me write the stuff over here. So the domain of the given function is all real values. Here we have a question. Why do we have to find domain to get x values for all critical points? Because the x values that I'm going to get for all critical points must be within the domain. So that's why. So first I find the domain of the given function. Okay, now let's see how to get the x values for all critical points. So to get x values for all critical points, what I have to do is I have to find the first derivative of the given function. Okay, now let me find the first derivative, that is f prime of x. So to get derivative for this stuff, 9 negative x square whole to the power of 3/5, first I have to do derivative for the exponent over here using the power rule of derivative. So once I'm done derivative for this exponent 3/5, by chain rule I have to do further derivative for the base, that is 9 negative x square. Okay, first let me do derivative for the exponent 3/5 using power rule. Power rule means I have to bring this exponent 3/5 in front of this, and then I have to subtract 1 from the exponent. Then I'm getting 3 over 5 times 9 negative x square whole to the power of 3 over 5 negative 1. So now I have completed derivative for the exponent 3/5. Now by chain rule I have to further derivative for the base 9 negative x square. Actually 9 is a constant. The derivative of this 9 is 0 negative. So the derivative of this x square with respect to x is 2x. Okay, now let's do some simplification over here. F prime of x equals to 3 over 5 times 9 negative x square. Now I have to simplify. That is, I have to do subtraction between the fraction 3/5 and the integer 1. So whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this 5 as a common denominator. Let me do it. 3 negative. I multiply this 1 and 5. 1 times 5 is 5. Now I can take the 5 as a common denominator. So 0 negative 2x will become just negative 2x. Then we get f prime of x equals to 3/5 times 9 negative x square whole to the power of, when I simplify 3 negative 5, I'm getting negative 2/5 times negative 2x. Okay, so here the exponent is negative. To make this exponent as positive, what I have to do is I have to move this term to denominator. So f prime of x equals to, now I'm going to move this term to denominator to make this exponent as positive. And also I can multiply this 3 and negative 2x, then I'm getting negative 6x over 5 times 9 negative x square whole to the power of 2/5. Okay, now I got the derivative of the given function f of x. So it becomes f prime of x equals to negative 6x over 5 times 9 negative x square whole to the power of 2/5. Okay, now what I'm going to do is I have to equate the first derivative to 0 and solve for x to get the x values for all critical points. Okay, now let me equate the first derivative to 0. That is f prime of x is equated to 0. Then we get negative 6x over 5 times 9 negative x square whole to the power of 2/5 equals to 0. Now I multiply both sides by the denominator what we have over here. That is 5 times 9 negative x square whole to the power of 2/5. Let me multiply the same thing on the right side as well. That is 5 times 9 negative x square whole to the power of 2/5. So this one will cancel out. I'm getting negative 6x equals to 0 multiplied by anything is still 0. Now I divide both sides by 6. So when I do so, this 96, 96 will cancel. I'm getting x equals to 0 divided by anything is 0. So when I equate the first derivative, that is f prime of x to 0, I'm getting x equals to 0. So this is the value of x on a critical point. Okay, so now we may have a question. So is this the only value we have for x that we have on the critical point? No, we have to do one more check. That is, we have to find the value of x for which f prime of x becomes undefined. So for what value of x this f prime of x becomes undefined? Actually, on the right side we have a fraction. If the denominator becomes 0, automatically the value of this fraction becomes undefined. That is, the f prime of x becomes undefined. So for what value of x the denominator becomes 0? So for that, we have to check for what value of x this 9 negative x square becomes 0. So what do we have to do for that? We have to equate that one to 0. Let me do it. Let's equate 9 negative x squared to 0. Now what I have to do is I subtract 9 from both sides. That is, I have to solve for x. So negative x square equals to negative 9. Now I multiply both sides of this equation by negative 1. When I do so, I'm getting x square equals to positive 9. Now to solve for x, I'm taking square root on both sides. Whenever I take square root on both sides of an equation, for one of the square roots, I have to consider positive or negative sign. Usually we consider positive or negative sign for the square root, which contains number inside. So this square root contains number inside. We can consider positive or negative sign for this square root. And here on the left side, the square root and square root cancel out, x equals to positive or negative. And when I take square root of 9, I'm getting 3. So we get x equals to positive or negative 3. So when I plug in either x equals to positive 3 or negative 3 over here, this x square will become 9, 9 negative 9 will become 0. So the denominator will become 0. So then f prime of x becomes undefined. So for these two values of x equals to positive 3 and x equals to negative 3, so the denominator over here in f prime of x becomes 0. So f prime of becomes undefined. So there are three values we get for x. For all critical points, already we got the first value over here, that is x equals to 0. Now we got two more values over here, that is x equals to positive and negative 3. Okay, now let me write all the values over here. So that is x equals to negative 3, 0, 3. And also we have to make sure one more thing, that is the x values we get for all critical points over here must be within the domain, as I said earlier. So domain is all real numbers. So here all the three values we get for x for all critical points, all real numbers. So we have all these three values are real numbers. So these are the x values we have for all critical points of the given function.